Hey boys and girls, welcome back to Mr. Sitobaka's geometry class. Here's what we're working on today, so go ahead and open up your ebook to this lesson. Feel free to pause the video if you need some time to get there. And don't forget to take out a pencil and paper to copy down today's lesson target. Feel free to pause the video if you need a second to get those out and copy it down. Ready to start this journey? Let's go! Hey everyone, Mr. Sitobaka here. Okay. Boy, that's really humbling to hear. Such appreciation. It means a lot. Now, if you haven't had me as a teacher, or you have, either way, I'm glad to get this opportunity to interact with you, even though it's through a video. However, in this, I'm going to encourage you to do as much as you can on your own. You're going to be tempted in this video to just hit play and go through it and let me do the work. But as you'll see, I'm going to suggest that you pause the video and you try to do a problem and then you hit play when you're ready. That's the best way to do this. If you just let it go through and have a teacher do all the work for you, it's kind of like expecting to learn how to drive when you're sitting in the driver's seat. Like I'm over here driving and you're just sitting there watching me. You're not going to learn how to drive very well. The only way for you to learn to drive is if you get in the driver's seat yourself and you control the car. The same way to do that here is by hitting pause and doing those problems yourself, making mistakes. It's okay to make mistakes. And then checking with the video and learning from that. You can do it. I hope these help you, and I wish you all the best. Today we begin Chapter 4 with Lesson 4.1.1. What patterns can I use? Constant ratios in right triangles. In Chapter 3, you looked for relationships between triangles and ways to determine if they are similar or congruent. Now you're going to focus your attention on slope triangles, which were used in algebra to describe linear change. Are there geometric patterns within slope triangles themselves that you can use to answer other questions? In this lesson, you will look closely at slope triangles on different lines to explore their patterns. Problem 4-1 involves a situation with the Leaning Tower of Pisa. But before we get into that problem, let's watch a quick video on this tower.
Leaning Tower of Pisa, very special because this building actually leans. I mean, how can a building lean and still be standing? Could it be a hoax? Well, it turns out it's not a hoax. We are looking at the Leaning Tower of Pisa and it does in fact lean to its right. This tower has a height of about 58 meters, with an inclination of over 4 meters. Imagine, it has been tilting for almost 7 centuries now. This tower has 6 open galleries. The tower architecture is remarkable as well. Its construction was started in 1174. When it reached the 3rd floor, the tower started sinking, due to which construction stopped for nearly a century. The tower was originally meant as a bell tower. The bell chamber at the top holds a total of 7 bells. Let's take a look. To reach the bell chamber, I have to climb a flight of 294 spiral steps, and I'm totally short of breath. Whew. We made it! The 7 bells have been tuned to represent the 7 notes of the musical scales. And this is l'Assunta, the largest of these bells, installed in 1655. This grand monument continues to sink, but advanced technologies are being used to minimize that, and we hope this fascinating tower lasts for centuries to come. I'm Vasco Dossi showing you Pisa.
Okay, now that you know a little bit more about the Leaning Tower of Pisa, let's jump into this problem. At this point, I would like you to hit pause and read through problem 4-1, and then try to complete letters A, B, and C to your best ability. When you've done so, hit play again. Okay, so as you read, the tower is in danger of collapse. In fact, they say if this angle here falls below 83 degrees, then the tower is going to fall over. So what is that angle? Well, letter A asks us, with the measurements provided above, what can you determine? And so as you see here, we have a right triangle, and they give us the two legs, 50 and 5. They don't give us this side of the right triangle, which is called the hypotenuse. And so that's one thing we can find using the Pythagorean theorem. So we can find the hypotenuse of the right triangle. Now, you don't actually have to find that. They just want to know what you can find. If you did want to, you would simply go 5 squared plus 50 squared equals c squared. This equals 2,525. You take the square root of both sides and get c is approximately 50.25 meters. Letter B asks us, can you determine the angle at which the tower leans? So this angle here is what we're talking about. And you may have thought, yeah, I can just put a protractor up against the image and find the angle that way. That's a great idea. However, in this problem, this drawing is not necessarily to scale. And so what they want to know is, can you find that angle given only the information that we have here? Those three sides. And unfortunately, in this course, you have not been taught that yet. And so our answer is no. But we're going to add not yet, because there is hope. In letter C, they tell you at the end of section 4.1, which is this lesson and the next few lessons, after those, you will know how to find the angle for this situation and many others. Pretty cool. You are going to acquire a new skill in only a few lessons to where you can find this angle only given that information. The end of letter C asks you how else you can describe the lean of the Leaning Tower. Whatever you wrote there is fine, and you are now ready to watch the next video in this lesson. Good luck.